Hi there. In this video, we'll learn about the crossover discount rate, which is an interesting phenomenon when it comes to comparison between two projects. While comparing two projects, we usually use NPV criterion. And when we do this, we have to be careful because if we continue increasing the discount rate, the NPV can reverse in terms of its signals. Let us see how this can happen. When we are comparing two projects, for example, project A and project B, their NPVs will be represented like this, and they will give us not the same indications for all of the discount rates. How? Let us see. NPV and IRR may not always recommend the same project. We have seen that at times NPV and IRR give different results. We will see in this example that they are giving opposite recommendations. At the end we will see this. But when it comes to NPV, let us consider that at a certain discount rate, the NPV of A project is greater than that of project B. But it can reverse. How it can reverse? If we continue increasing the discount rate, it might reverse after a certain increase in discount rate. Let us consider this in the form of a diagram. Here on x-axis we have discount rates and on y-axis we have NPV. This is the origin, and we can see that there are two curves. One is for project A and the other one is for project B. Here we can see that project A is more desirable because at this discount rate the project A is having a higher level of NPV, whereas project B at the same discount rate is having a lower level of NPV. Here both of them are equal. The same discount rate will give rise to same level of NPV for both of the projects. But after it, you can see the lighter shade of the line. It is above the darker shade of the line, and it means that project B has a greater NPV as compared to the project A. So the findings are reversed here after this point. The intersection of x-axis and the NPV curve, it will give us the IRR, and this will be for project B and this will be for project A. So this is that discount rate after which the NPV comparison will reverse. This is why we call it a crossover rate or crossover discount rate. These are the same things that we have understood with the help of diagram. The crossover discount rate or crossover rate, it reverses the things, and before it project A is preferable in this diagram, and at it A and B are equally preferable, and after it B and A are now in an opposite situation where B is preferable to project A. So these are the various situations in the symbolic terms. Now we can do a numerical exercise to ascertain the things that we have learned. We have a project A and we have a project B. Both of them have their own streams. Here we have years from 1 to 10, and again here the stream is the same. Capital costs are listed here for project A. Capital costs are listed here for project B, and O&M costs are there for project A and for project B as well. We can sum them to get the total costs, and we also have the benefits column for both of the projects. So now we can easily calculate the net benefits for project A and net benefits for the project B. Then we have to do a new thing that we haven't done before. We can calculate the NPV for project A and for project B by using these net benefits. These calculations are not done in details here. You can pause the video and do it. Now these calculations are at 12% discount rate. This is the new thing that we will calculate here. This is the differential of the net benefits by subtracting net benefits of A from net benefits of B. Differential net benefits is a suitable term for it. You can see that it's easy to calculate. -10 minus minus 20 will become 10, and in the same way for all these rows we can calculate the net benefits differential. And the NPV can also be calculated here. An approximate value is given. So the purpose of calculating this differential is simple, and it is evident from this diagram, because this is that discount rate where the difference between the two NPVs will be 0, because we want to compare these two, and the comparison is with the help of these two lines, and this is that rate where the difference of the NPVs will be equal to 0. So actually we are trying to calculate the NPV for this area which is between the two lines, here and then here. This is that stream that we are considering. We are not considering the whole of the stream away from the origin, and it is between these two lines. So this is that point where the difference of the two, that is the difference of the two NPVs, will be equal to 0. So if we can calculate the difference and then we can calculate the discount rate at this, it will be equal to the IRR methodology, and it will be equal to crossover discount rate. So this is the logic of calculating the difference of the two net benefits that we can use to find out the crossover discount rate. So this is what we understood, that if we calculate the IRR for this difference in the cash flows of the two projects, we will get the crossover discount rate. Now we have NPV profile, making NPV profile for project for the sensitivity to the range of the discount rate. In the NPV you will see that we will calculate NPV for a range of discount rates, for example starting from 0 and going to any level of discount rates. So this is the NPV profile. This is the discount rate. As we said that a range of discount rates will be used. We have taken a difference of 2. It could have been 1, but we wanted to keep it brief because that's the point where we want to be. And if we had chosen all the values, that is 1, 2, 3, 4, then definitely a lengthier table would have been generated. So for the sake of ease, we have omitted one value from each of the two values. NPV for 0 and discount rate will be this. NPV at 2% discount rate will be this. So you see that NPV is being calculated on various discount rates. And then NPV of project A at 0% discount rate, NPV of project A at 2% discount rate, and in the same way NPV of project B at, for example, 6% discount rate. So this was the NPV profile. Now how can it be useful for us? Let us see that how the comparison is working, because till this point we can see that all the NPV of A, they are greater than that of NPV of B. 151 is greater than 139. 44.79 is greater than 44.52. So the comparison is clear, but after this the comparison gets reversed, that at 14% the NPV of project A has become smaller as compared to NPV of project B, and then further it remains in the same pattern at 16% discount rate, 27 versus 29. So see, as we are going ahead, NPV of A is smaller as compared to NPV of B. So from here the pattern has reversed, and it is between 12% and 14%. So there are two discount rates and there are two NPVs. So in this situation we remember that we can use the interpolation formula. Diagrammatically speaking, you can see that the two NPV curves are there. NPV of A is in orange line and NPV of B is in gray line, and the NPV of the difference of the two net benefits is in blue line. So it is here, and we can see that crossover is happening somewhere here. It is not drawn to the scale, but if you draw it to the scale, you will definitely see that this overlap is happening at somewhere in the middle of 12% and 14%. So you can see that it's happening somewhere here, the overlap. So this is how it is, the overlap happening at this point, that is 12 and 14, somewhere in the middle. Now we can do this interpolation. Here we can see the interpolation is done. It is the same formula, however, we are using the modular sign on NPV lower because we have seen that NPV lower is negative here. So after doing this, we can do the calculations and find out that the answer is 12.610%. This is by interpolation, and we know that interpolation can be an overestimated process, due to which there will be an overestimated value. And by the precise calculations using a computer, we will get some other discount rate. We will see that just in a while we go through this summary. The summary of findings can be very helpful to understand the whole situation. We have chosen 12% discount rate. In the very beginning, we found that the NPV of project A by using the discount rate, which is 12%, will be this. Similar calculation for project B will be this. Project A is preferable to project B at 12% discount rate. Here we can clearly see that project A is desirable, as we saw in the diagram as well. And then IRR for both is calculated, and in this case IRR for project A is greater, for project B is greater. So this means that now project B is preferable if we choose the IRR criterion. And we know already that these two criterion can go in opposite directions, so this is not a surprise. So main purpose right here is to see that how these two projects can be compared when it comes to increasing discount rate. So NPV, if we calculate it for the difference of the two net benefits at 12% discount rate, will be equal to minus 0.028. So this is how it is. At 12%, it has a negative NPV. Now the crossover discount rate, the main thing that we were trying to calculate. 12.45, whereas this is 12.61. So the overestimation is evident, which is nothing surprising again. This is a more precise value of the crossover discount rate. And then we can calculate the NPV for project A, for project B by using the crossover discount rate. And they should be equal because that is actually the crossover of the two NPV curves. So it is the same. So the NPV is same at crossover discount rate for both project A and B. The intersection of the two curves is happening. Finally, the NPV of the differential stream at crossover discount rate should be equal to 0. So it is approximately equal to 0. And this verifies that our crossover discount rate is actually a correct value that we have calculated. So this is the thing, that before 12.453% discount rate, project A would be better as compared to project B, whereas after it, project B will become more desirable as compared to project A. So this is how the reversal happens between the two NPVs of the projects when it comes to an increasing discount rate. This was the numerical example, this was the diagrammatical depiction, and this is basically the main topic, in which we have understood that we should keep an eye on the discount rate because after a certain value, the preferable project A will not be preferable anymore, and this will reverse our findings, and hence the decision of choosing the project may also change. Thank you.